In the previous activities, you learned how to declare variables, assign values to them, and perform basic type conversions. You now have the building blocks to store information in your Python scripts. However, a script that always executes the same instructions in the same order, regardless of what is happening, is of very limited use in a security context. Real automation requires the ability to react to situations. If a port is open, do something. If a password does not match, block access. If a response code indicates an error, raise an alert. This ability to react to conditions is called conditional branching, and it is implemented in Python using the if, elif, and else keywords. Understanding a condition. A condition is a Python expression that evaluates to either true or false. These two values are called Boolean values, of type bool. When Python encounters a conditional instruction, it evaluates the expression you provide and decides which block of code to execute depending on the result. Here are the most common comparison operators used to build conditions. Means is equal to. For example, status underscore code equals 200 evaluates to true if the variable status underscore code holds the value 200. Means is not equal to. For example, response equals OK evaluates to true if response does not contain the string OK. Greater than means is greater than. For example, attempts greater than 3 evaluates to true if attempts is 4, 5, or any number above 3. Less than means is less than. For example, risk underscore score less than 10 evaluates to true if risk underscore score is 9, 8, or anything below 10. Greater than equals means is greater than or equal to. For example, port greater than equals 1024 evaluates to true if port is exactly 1024 or any larger number. Less than equals means is less than or equal to. For example, retry underscore count less than equals 5 evaluates to true if retry underscore count is 5 or less. Note that a single equals sign equals is an assignment, you store a value, while a double equals sign equals is a comparison, you test a value. This is one of the most common mistakes made by beginners, and it matters a great deal in security scripts where a wrong assignment instead of a comparison could silently bypass a check. The basic if structure. The simplest conditional structure has only one branch. The syntax in Python is if condition. Instruction underscore to underscore execute. Python uses indentation, spaces at the beginning of the line, usually 4 spaces or 1 tab, to define which instructions belong to the conditional block. This is mandatory in Python. If you forget the indentation, the script will raise an error. Here is a concrete example. Imagine you are writing a script that checks whether a network port is considered privileged. Port equals 80. If port less than 1024. Print. This is a privileged port, root access may be required. In this example, Python evaluates port less than 1024. Since 80 is indeed less than 1024, the condition is true, and the print instruction is executed. If port had been set to 8080, the condition would have been false, and nothing would have been printed. Adding an else branch. Often, you want to specify what should happen when the condition is false. This is done with the else keyword. If condition. Instruction underscore if underscore true. Else. Instruction underscore if underscore false. Using the previous example. Port equals 8080. If port less than 1024. Print. This is a privileged port, root access may be required. Else. Print. This is a non-privileged port. Here, since 8080 is not less than 1024, the condition is false, so Python skips the first block and executes the else block, printing this is a non-privileged port. The else branch catches every case not matched by the if condition. It has no condition of its own, it simply runs when the if condition is false. Handling multiple cases with elif. Sometimes you need to test several possible conditions in sequence. Python provides the elif keyword, short for else if, for this purpose. You can chain as many elif blocks as needed between the if and the optional else. If first underscore condition. Instruction underscore A. Elif second underscore condition. Instruction underscore B. Elif third underscore condition. Instruction underscore C. Else.instruction underscore D. Python evaluates conditions from top to bottom. As soon as one condition is true, the corresponding block is executed and the rest are skipped. The else block at the end only runs if none of the conditions above it were true. Here is a practical security-oriented example. Suppose you are writing a script to classify a hypertext transfer protocol response code. Status underscore code equals 403. If status underscore code equals 200. Print request successful. Elif status underscore code equals 301. Print permanent redirect detected. Elif status underscore code equals 403. Print access forbidden. Check authentication or permissions. Elif status underscore code equals 404. Print resource not found. Elif status underscore code equals 500. Print internal server error. Potential vulnerability or misconfiguration. Print unknown status code, plus str status underscore code. With status underscore code set to 403, Python tests each condition in order, finds the match at the third elif, prints access forbidden, check authentication or permissions, and stops evaluating further conditions. Combining conditions with logical operators. You can combine multiple conditions in a single if or elif line using logical operators. And both conditions must be true for the overall expression to be true. For example, port greater than equals 1 and port less than equals 65,535 is true only if port is within the valid range. Or, at least one of the conditions must be true. For example, protocol equals HTTP or protocol equals FTP is true if the protocol is either HTTP or FTP. Not inverts a condition. For example, not is underscore authenticated is true if is underscore authenticated is false. Here is an example combining and. Username equals admin. Password equals secret123. If username equals admin and password equals secret123. Print access granted. Else. Print access denied. Both conditions must be true simultaneously for access to be granted. If either the username or the password is wrong, the else branch executes. Here is an example using OR. File underscore extension equals exe. If file underscore extension equals exe or file underscore extension equals bat or file underscore extension equals ps1. Print warning, potentially executable file detected. Else. Print file extension appears safe. And an example using not is underscore SSL underscore enabled equals false. If not is underscore SSL underscore enabled. Print warning, connection is not encrypted, sensitive data may be exposed. Nested conditions. You can place an if/else structure inside another if/else structure. This is called nesting. Each nested block must be indented further to the right than its parent block. Port equals 443. Protocol equals HTTPS. If port equals 443. If protocol equals HTTPS. Print secure web traffic on standard port, else. Print port 443 used with an unexpected protocol. Else. Print non-standard port for web traffic. Nesting allows you to model more complex decision trees, but deep nesting can quickly make code hard to read. As a general rule, try to keep nesting shallow by combining conditions with and or when possible. The importance of indentation. Unlike many other programming languages that use curly braces to delimit code blocks, Python relies entirely on indentation. Every instruction that belongs to a conditional block must be indented consistently. Mixing tabs and spaces, or using inconsistent numbers of spaces, will cause Python to raise an indentation error. In your editor, it is recommended to configure it to insert 4 spaces whenever you press the tab key, to keep your code consistent and readable. Practical security use cases. Understanding conditions is essential for security automation. Here are several real-world scenarios where if/else conditions are central. Checking whether a user-provided input matches an expected format before processing it, to avoid injection-type vulnerabilities and scripts that interact with external systems. Verifying that a file size does not exceed a defined threshold before uploading or analyzing it, to prevent denial of service situations. Classifying network scan results. If a port is open and belongs to a list of sensitive services, flag it for further investigation. Automating responses to alerts. If a log entry contains a specific keyword such as failed login, increment a counter and trigger a notification if the count exceeds a threshold. Here is a brief example of the last scenario. Failed underscore attempts equals 7. Threshold equals 5. If failed underscore attempts greater than threshold. Print alert, suspicious number of failed login attempts detected. Account may be under attack. Else. Print number of failed attempts is within acceptable limits. Summary of key points. To summarize what you have learned in this section. A condition is a Boolean expression that evaluates to true or false. The if keyword introduces a block of code that runs only when the condition is true. The else keyword introduces a block of code that runs when the if condition is false. The elif keyword allows you to test additional conditions in sequence, between if and else. Python evaluates conditions from top to bottom and stops at the first true condition. Logical operators and not allow you to build complex conditions from simpler ones. Indentation is not optional in Python. it defines which instructions belong to which block. Conditions are at the heart of any automation script, especially in security contexts where decisions must be made dynamically based on observed data. With these foundations, you are ready to write Python scripts that respond intelligently to the data they encounter, which is a critical skill for any security automation or DevSecOps task.